Hello students, in today's lecture we are going to learn about laws of motion NCERT section 4.8 to 4.9.1. Disclaimer: the images, text and other materials used in our presentation are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the content immediately. Please note that parts of the content may have been generated using generative AI, which is experimental. Learning objective: by the end of this lecture, you will able to understand the concepts of equilibrium of particle, common forces in mechanics, static friction, limiting friction and kinetic friction. So in today's lecture we will cover 4.8 equilibrium of particle, 4.9 common forces in mechanics. After that we will learn 4.9.1 friction. So topic is equilibrium of a particle. Now here question arises, what is equilibrium? What is equilibrium? A system is said to be in equilibrium when both the net force and net torque acting on it are zero. It means what? It means when the net force means sum of all forces acting on a particle is zero, the particle is said to be in equilibrium. Mathematically, the sum of all forces, this is summation F equal to 0, means sum of all forces should be equal to 0 if we talk about the equilibrium condition. According to Newton's first law, when a particle is in equilibrium, it will either remain at rest if it was initially stationary, continue moving with constant velocity if it was initially in motion. It means the net force on a particle should be 0. Clear? Simple two force cases. Here we will understand the equilibrium with the using of two force case. When only two forces act on a particle in equilibrium, in that case the force on a particle should be F1 is equal to minus F2. So force is equal and opposite. Force must be equal and opposite. So this comes from the Newton's third law of motion. For example, suppose we have a book and book on a table. Look at here, book on a table. So there is a two forces, F1 and F2. F1 force is the weight of the book, whereas F2 force is reaction force on the table, reaction force of the table. So weight of the book, that is acted vertically downward. The direction of weight of book is downward direction. F1 is vertically downward. Whereas if we talk about the reaction force of the table, that is normal force from the table and direction is upward. Direction is upward. these forces are equal and opposite. It means what? It means F1 is equal to F2, but the direction is opposite. So in that case, when the forces must be equal and opposite, the book remains at rest. So this is the condition of the equilibrium. The net force on a particle, or we can say the net force on a system, should be 0. Clear? Now, suppose if we have 3 concurrent forces. So in that case, the equilibrium under 3 concurrent forces. So we have a 3 forces F1, F2, F3. Equilibrium under concurrent forces. So equilibrium under 3 concurrent forces, that is F1, F2 and F3, requires that the vector sum of the 3 forces is 0. So we know equilibrium, if we talk about the equilibrium condition, the net force on a system, or we can say the net force on a particle, should be 0. So here we have a 3 forces F1, F2 and F3. So in equilibrium condition, the net force is the sum of vector sum. Net force is vector sum equal to 0. Mathematically, vector sum of 3 forces is 0. Look at here. So here we have a 3 forces F1, F2, F3. So for the equilibrium condition, it should be 0. The resultant of any 2 forces must be equal and opposite to the third force. It means, suppose we have a 2 forces F1 and F2. In that case, the resultant of the 2 forces must be equal and opposite to the third force. Let's see. So suppose we have a 3 forces F1, F2, F3, and according to equilibrium condition, the net force on a particle should be 0. So the net force, the resultant force on any two, the resultant of any 2 forces is F1 and F2 is equal to minus F3 here, or we can say 2 forces must be equal and opposite to the third forces. So here third force is F3 and sum of 2 forces F1 and F2. Similarly, F2 plus F3 equal to minus F1. So it shows the resultant of any 2 forces. Here any 2 forces is F2 and F3 is equal and opposite to the third force. So here third force is F1, and we know minus sign indicates the direction. Minus sign indicates the direction. So this is the equilibrium under the 3 concurrent forces. So suppose we have a 3 forces and we have a 3 forces. So the resultant force of any 2 forces F1 or F3, F1 and F3 is equal to equal and opposite to the third force. So here third force is minus F2. Minus sign indicates the direction. Clear? So this shows the resultant of any 2 forces must be equal and opposite to the third force. This is the equilibrium condition. Clear? So in 4.7, equilibrium under concurrent forces, we have a forces F1 and F2, and third one is here F3. So we can say equilibrium under 3 concurrent forces, the resultant of any 2 forces must be equal and opposite to the third force. in mechanics, we encounter several kinds of forces, and these forces are friction force, drag force, tension, spring force, pseudo force, etc. So these are the common forces in mechanics. They are seen in most of our daily life problems. Hence, we call them common forces in mechanics. Now, we will learn common forces in mechanics, that is friction force, tension force, spring force, one by one. So let's understand the concept of force and the different nature of these forces. So for here we have a first force, spring force. Spring force. Now here question arises, how we can define the spring force. Look at here. Here we have a spring mass system. The length of the spring is L naught and the mean position is this one, 0. So the spring force, we can define the force exerted by a spring, when it is stretched or compressed. So here we have a spring, the length is L naught. When we stretched or compressed, so there is a change in position of the block, or we can say there is a displacement. There is a displacement of the block when we stretched or compressed the spring. This force is proportional to the displacement. The force exerted by the spring is proportional to the displacement by the block, or we can say by the displacement of the spring from the equilibrium position. So here equilibrium position is this one, the center of the this L naught. 0 is the here equilibrium position. So the when we stretch the spring, the position of the block will be changed. So there is a displacement, and that displacement is proportional to force, applied force by the spring. Mathematically, we can understand it. So F is equal to minus kx. This is the Hooke's law. F is equal to minus kx, where x is the displacement and k is the spring constant. So this is the Hooke's law. Clear? Here k is spring constant. K is spring constant, or F is the force exerted by the spring. Unit is Newton per meter, and x is the displacement of the springs, and negative sign shows the force is always to the direction of displacement. Here listen carefully. If you stretch the spring positive towards the positive x, it pulls back, and if you compress the spring towards the negative x-axis, it pushes back. The further you stretch or compress, the stronger the restoring force, according to Hooke's law. And the value of k, that is spring constant, is a the numerical value is given according to the material of the spring. So let's talk about a real life use of the spring. So this type of system commonly used in homes or shops to weigh LPG gas cylinders. Yes or no? Also used to labs to measure the force or mass of hanging objects. Clear? Next force is tension force. Tension force is the force is experienced by a rope or a string which holds an object. The tension force is always a pull, not a push. The tension force is same throughout the cable. For example, a ball hanging with the help of a string. Look at here. Here we have a string and ball that is hanging with the help of a string, and the tension force that is acting here is like this, in upward direction, and weight of the wall is vertically downward, that is mg. Clear? Next force is buoyant force. So if we talk about the buoyant force is the upward force exerted by a fluid on an object submerged in it. So look at figure. Here we have a block. And when the block is submerged in the liquid like this, the weight is acted vertically downward, and the buoyant force that is acted on the block acted on upward direction, as shown in the figure. So here question arises, why does it happen? Because pressure in fluid increases with depth. The force arises because the pressure within the fluid increases with depth. The pressure at the bottom of an object submerged in fluid is greater than the pressure at the top, resulting in a net force upward. So the pressure, if we talk about the pressure at bottom and the pressure at the top, so in both cases pressure at the bottom is greater than the pressure at the top. So in the buoyant force of an object immersed in a fluid equal to the weight of the fluid it displaces. So when we drop a block in the liquid, so there is a displacement of water, or we can say displacement of fluid, and the weight of the fluid is equal to the weight of the block according to Archimedes principle. So for example, for a solid immersed in a fluid, there is an upward buoyant force equal to the weight of the fluid displaced. Clear? So suppose, listen carefully, suppose when you put any object in the water or any fluid, it feels lighter or may even float. That's because the fluid pushes the object upward with a force. This upward force is called buoyant force. Here the upward force is buoyant force, also called upthrust. This happens because fluid pressure increases with depth, and at the bottom of the object is deeper in the fluid than the top. So bottom experience more pressure than the top, and the difference in pressure at a net upward force is equal to buoyant force. Clear? This resistance is represented by a single force and called friction force. Friction force. The force of friction is parallel to the surface and opposite to the direction of intended motion. So look at here, the direction of motion is towards downward, and the friction force that is acted between the body and the surface is the direction is upward, and the direction of force of friction and a surface both are parallel, and the friction force and the motion of the body are opposite to each other if we talk about the presence of friction. Clear? So it means the friction direction of friction and the direction of motion both are opposite to each other. Types of friction. First is static friction. Here we will learn static friction, kinetic friction, limiting friction. So first is static friction. So here question arises, what is static friction? Static friction is the opposing force that comes into play when objects are at rest. Static friction is a self-adjusting force because it changes itself in accordance with the applied force. So here static friction is equal to pressure. Simple idea, if we talk about a simple idea, imagine you are trying to push a heavy box on the floor like this. This is a block and you are trying to push a heavy box on the floor. At first the box does not move. Yes or no? That's because static friction is holding it in place. So due to the static friction, the box does not move. You applied force in the forward direction and the static friction is opposite direction of your force in backward. Here like in LHS, Fs is acted in left side and RHS right, the force that is acting right hand side is applied force. So if the applied force is less than the static frictional force, in that case the box does not move because the static friction is holding it in place. Or we can say static friction is a self-adjusting force. Second is limiting friction. Limiting friction. The maximum value of static friction up to which body does not move is called limiting friction. We can say it's the greatest possible value of the static friction. The magnitude of the limiting friction between any two bodies in contact is directly proportional to the normal reaction between them. So limiting friction is directly proportional to normal reaction. So to removing the proportionality sign, there is a constant, that is mu s. So FL is equal to mu s n. Limiting friction is equal to mu s into normal. And the direction of the force of the limiting friction is always opposite to the direction in which one body is at the verge of the moving. When you slowly increase the force on a restricting object, a static friction increases to match it and keep the object still. But there is a limit, and that is limiting friction. As soon your force exceeds the limiting friction, the object starts moving. So this is the concept of limiting friction. So suppose if we let's take an example to understand the limiting friction. Listen carefully. You try to push a box with increasing force. You try to push a box with increasing force. At 5 Newton, no motion, and static friction is suppose 5 Newton. So at 10 Newton, no motion, because static friction is also in second case also 10 Newton. At 15 Newton, just starts to move, because here we choose the static friction is less than the applied force. Coefficient of static friction, mu s. Mu s is the coefficient of static friction, is called coefficient of static friction. Dimension formula m0 l0 t0. This is the dimensionless quantity. Unit is, it has no unit. Value of mu s lies between 0 and 1. Value of mu depends on material and nature of surfaces in contact. If the material is changed, the value of mu will also change. Value of mu does not depend upon the apparent area of contact. It is independent. Here, this is dimensionless. So, third is kinetic friction. So, kinetic, this is the responsible for the impending motion. Kinetic friction or dynamic friction means if the applied force sets the body in motion, the friction opposing the motion is called kinetic friction. So kinetic friction depends upon the normal reaction. So Fk is directly proportional to N. So for removing the proportionality sign, there is a constant, and that is mu k. So Fk is equal to mu k N, where mu k is called the coefficient of kinetic friction. Look at here, 4.10 B graph. Your applied force is F, and the kinetic friction, that is Fk. When the applied force is greater than the kinetic friction, in that case block will be moved. Once a body is in motion, it is subjected to sliding or kinetic friction, which opposes the relative motion between the two surfaces in contact. Or we can say kinetic friction is less than the static friction. Kinetic friction is always lesser than limiting friction, so Fk is less than Fl. Thus, we require more force to start a motion than to maintain it against friction. This is because when motion has actually started, irregularities of one surface have little time to get locked again into the irregularities of the other surface. So, The in simple words we can say uh, kinetic friction is less than limiting friction. Summary. First, equilibrium of particles. A particle is in equilibrium when all forces acting on it sum to 0. Summation of all forces equal to 0. Both horizontal and vertical components must balance in equilibrium condition. Second is buoyancy. Buoyancy that acts vertically upward, and direction in the direction is vertically upward, and force exerted by fluids on immersed objects, and that is equal to the weight of the fluid displaced according to Archimedes principle. Tension. Force that pulls equally at both ends of a string, rope or cable. Always acts along the length of the object. Hooke's law. F is equal to minus kx. This is the mathematical form of Hooke's law. Spring force is proportional to displacement. We already learned this. K is the spring constant. Friction, static friction Fs prevents motion between surfaces at rest. So Fs is less than equal to mu s n, where n is the normal force. Kinetic friction Fk that opposes motion between sliding surfaces. So Fk is equal to mu k n. Here mu k is less than mu s. 6 is limit of friction. Maximum static friction occurs just before motion begins, determined by coefficient of static friction. Now we have some practice questions. Please note down. First is, what condition must be satisfied for a single particle to be in equilibrium? State them mathematically. So in this question you have to find out the equilibrium condition mathematically. So mathematically we can say net force on a particle should be 0. Yes or no? Second is, if a spring's length doubles, the length of the spring double, when a 10 Newton force is applied, what is its spring constant? So here you have to find out the spring constant. We know Hooke's law, F is equal to minus kx. Here F is given, that is 10 Newton, and length is doubled. Third question, why is static friction typically greater than kinetic friction between the same surface? This is the third question. Fourth is, a block weighing 50 Newton is placed on a surface with coefficient of static friction mu s is equal to 0.4. What is maximum force can be applied horizontally before it starting moving? Fifth, how does normal force affect the maximum force? Express the relationship mathematically. Thank you for your attention. So click on DPP. So first question, for a particle to be in equilibrium under the action of the three concurrent forces, which condition must be satisfied? So first is, the forces must be equal in magnitude. Second, the vector sum of the forces must be 0. And C is, the force must from a right angle triangle and all forces must act in same direction. So in this question you have to find out the correct option. Which one is correct? Please answer. you have to find out the equilibrium condition under the action of three concurrent forces. Which one is correct? A, B, C or D? Next question. If three forces F1, F2 and F3 acting on a particle are in equilibrium, how can they be represented geometrically? Option A, as sides of an open polygon with arrows in the same sense. B, as side of a closed triangle with arrows in the same sense. As sides of a closed polygon with arrows in the alternating senses. As three collinear vectors of equal magnitude. Please answer. Yes. Third is, which set of equation must hold true for particle in a equilibrium under the forces F1, F2, F3. So here we have some forces and you have to find out the which one relation is under equilibrium of particle. Please find the correct answer. A, B, C, D, which one is correct? Yes. Which one? The algebraic sum of the components of all forces along each axis, x, y and z axis, must be individually equal 0 for equilibrium. So this one. If two forces of equal magnitude F are acting at a point and magnitude of their resultant is also F, then what is the angle theta between two forces? Option is 60 degree, option B 90 degree, 120 degree and 180 degree. So we know the formula of resultant force, R square is equal to F square F1 plus F2 square plus 2F square cos theta. So solving this you will be get R square is equal to 2F square 1 plus cos theta. 1 plus cos theta. So R is here 1. So it will be 1 equal to 2, 1 plus cos theta. So theta will be equal to cos theta equal to minus 1 by 2. So theta equal to cos inverse minus 1 by 2. Cos inverse minus 1 by 2 means theta is equal to 120 degree. Yes, right. 120 degree. A particle is acted upon by two forces F1 and F2 for equilibrium. What must be true? Option A, F1 and F2 are equal in magnitude and opposite in direction. B, F1 and F2 are perpendicular to each other. F1 and F2 have magnitudes in the ratio 3:4 and F1 F2 acts in same direction. Please answer. So here we select you have a 1 minute to solve this question. Yes, please answer. All of you, please solve. Now save and submit. So all questions are right and these are the solutions of question first, second, third, fourth, fifth. And if you have any doubt, please ask. If you have any doubt, please ask in any questions. Good. In this question, we have to find the angle. So if two forces of equal magnitude F acting at a point and the magnitude of their resultant is also F, here R and F both are equal, then what is the angle theta? Here you have to find out the angle theta. So the formula is two forces of magnitude F and their resultant is R equal to F according to question. So using the law of cosines for the triangle formed by the forces, R square is equal to F square plus 2F square cos theta because R equal to F. So F square is equal to 2F square 1 plus cos theta. Here we choose F2F square common. So F is 1. So because FF cancel out. So 1 equal to 2 1 plus cos theta. So it become 1 equal to 2 plus 2 cos theta. So 2 1 minus 2 minus 1 equal to 2 cos theta. So cos theta equal to minus 1 by 2. So theta equal to cos inverse minus 1 by 2. So cos inverse minus 1 by 2 is 120 degree. Clear? Thank you for your attention.